Now it is clear, right?
Yes, sir.
Yes, sir.
Okay. So listen. So we need to know what are triangle of vectors. So basics, I hope you already know. Vectors means physical quantities which have magnitude and direction. Similarly, there are different types of vectors like equal vectors, opposite vectors, and all those things that we will see as we apply we solve it in problems. So the main context you need to know is triangle of vectors. So what do you mean by triangle of vectors? If two vectors are taken along the direction and magnitude of two sides of a triangle in order. Okay. So what is the difference between the first diagram and second diagram?
Second diagram is in order. First diagram is in.
It's not in order. Yes, that's right. So for you to apply triangle of vectors, the first thing that you need to verify is what? You need to have two vectors which are considered along the side of a triangle in which direction? In order, in such a way that the closing side of the triangle will be equal to the sum of the other two sides. Okay, and the closing side should be taken in which order? It should be taken in the reverse order. So the meaning of it is, you have this as A vector, this as B vector, then this should be C vector, right? In such a way that A vector plus B vector will be equal to C vector. Accepted? So this is what is called as triangle of vector, addition of vectors. Similarly, you have something called as parallelogram law of vectors. So what do we mean by this?
So the diagonal.
Okay. So when will you apply parallel? When will you know? If a question is given, when will you know you are supposed to apply parallelogram law? When will you know we are supposed to apply triangle law?
Sir, if two vectors arise from the same point.
Yes. So what is the name of the technical name of those vectors? Two vectors starting from the same point are called
Co-initial.
yes. So if you have two co-initial vectors, okay, let's say A vector and B vector are given to us. If you have two co-initial vectors, then what will be the resultant of it? Then the resultant of
Between A and
tell
B.
me. It will be somewhere between A and B, and that between is nothing but if you are able to construct a parallelogram by considering two other vectors which are exactly parallel to A vector, which means this is also A vector, and parallel to B vector, which where this is also B vector, then the diagonal gives you the resultant of these two. If I take this as R, or I will call it as C, then can I write A vector plus B vector is equal to C vector? That is the meaning. A vector is one coinitial vector, one of the coinitial vectors, B is another coinitial vector, then C is the vector which is passing through the diagonal, which is the diagonal itself. Then here I am writing A vector plus B vector is equal to C vector. In triangle of vectors also I wrote A vector plus B vector as C vector. Then what is the difference between both? Why do we need to have two different laws?
Under different scenarios.
Sorry?
Under different scenarios.
No, not exactly. The point here what I am trying to make is both the laws are the same. Because when did I say you need to apply this one parallelogram law of vectors? When you have co-initial vectors, no? Observe the second diagram, see what I'm going to do. What is that you're able to see? Aren't you able to observe that both the diagrams are the same?
Yes, sir.
Yes. So one misconception many people have is they think triangle law and parallelogram law are different. No, they are not. Okay. So when you learned in CBSE for the definition purpose, statement purpose, and proof purpose, it was taught as two different laws, but remember they both are the same. Okay. Next. What is the magnitude of the resultant? This is what you need to know. So what will be the magnitude of this resultant? C is equal to root of a square plus b square plus 2 times what?
AB
AB. That's it.
cos theta.
What is theta there? What is theta here?
Angle between the two vectors.
Right. So it is exactly the angle made between these two vectors. Okay. Sometimes what they will do is, see, these are all the points that are important for you to understand the concept of relative velocity in 2-dimension also. So when they frame a problem, what they will do is they will ask what is the direction in which, let's say there is a rain and a man problem. You would have seen this problem. There will be a man standing and he will feel as if the rain is falling vertically. Suddenly what will happen is he'll be standing here, but wind will start blowing. Okay. That time what will happen, the rain instead of falling vertically, it will fall like this. Then they will ask the question like, in which direction is he supposed to hold the umbrella? So there, what they mean by direction is the angle at which he is supposed to hold with respect to either horizontal or vertical. Okay. So in physics, most of the cases, direction means angle. Okay. If I take this angle as alpha, then what will tan alpha be equal to?
B by A.
It is not B by A. It is B sin theta divided by A plus B cos theta. Okay. How it has come, I will show you. See, this is how the parallelogram is, right? This is A, this is A, this is B, this is B. If I take this as theta, if I drop a perpendicular, then this is also theta. Then this is B sin theta, and this will be B cos theta. Okay. So what is the base? Now what I'm going to do is, if I take this as the angle, observe, if I take triangle ABC, if I take the right angle triangle ABC, what is AB? A plus B cos theta. What is BC? It is B sin theta. Accepted? So this is alpha. Then what is tan alpha equal to? It is B sin theta divided by A plus B cos theta. Remember, wherever trigonometry has to be applied, you need to look for right angle triangles. That is what you need to search. Okay? So it is B sin theta divided by A plus B cos theta. Yesterday I would have told you, when you write a vector like this, A vector is equal to xi cap plus yj cap, then tan theta will be equal to y by x. Okay, I would have told this because here you are dealing with exactly perpendicular vectors. That is, x is in the direction of x-axis, y is in the direction of y-axis. So you're dealing with two components which are exactly in the perpendicular direction. That is why we wrote it as y by x, because what is the angle between x and y? Theta is 90 degrees. When you substitute theta is equal to 90 degrees here, okay, I will put it like this. This is tan alpha, where alpha is what? The direction. So if you put theta is equal to 90 degrees here, you will get b divided by a. Are you able to understand? So that is the reason why I told it is similar to y by x. I hope it is clear till this step. Right? Any doubt?
No, sir.
Okay. So going to the next concept. See, there will be some questions like this. Tan alpha is this much. Special cases. What if A vector's magnitude is equal to B vector's magnitude? If the magnitude of A vector is equal to magnitude of B vector, then what is the value of resultant? C is equal to, we know that it is root of a square plus b square plus 2ab cos theta. Right? It will be root of, what is a square? A square is a square only. B square is also a square plus 2 times a square cos theta. Accepted? So this will be root of 2a square plus 2a square cos theta. So it will be root 2 times a into root of 1 plus cos theta. Accepted? So what is 1 plus cos theta?
2 cos square theta by 2.
So you'll have 2 cos square theta by 2. So root 2 into root 2 is 2, 2a cos theta by 2. So this will be the value of the resultant. Then what is the angle made by the resultant with either of the vectors? What is the angle made by the resultant with the horizontal? That is, tan alpha is equal to, okay, what is tan alpha? B sin theta divided by a plus b cos theta. Here, what is happening between b and a? B and a are the same. So, can I write it as a sin theta divided by a plus a cos theta? Right. So, this will be a into sin theta divided by a into 1 plus cos theta. This and this will get cancelled. So, sin theta we can write it as 2 sin theta by 2 cos theta by 2 divided by 1 plus cos theta is 2 cos square theta by 2. 2 and 2 will get cancelled, cos and cos are common. So, what will the answer be? Which implies alpha is equal to theta by 2. Right? So, what is the meaning of this, guys? When two vectors are of equal magnitude, are of equal magnitudes, when two vectors are of equal magnitudes, what will happen?
The resultant is the angle bisector.
Yes, that's right. The resultant is an angular bisector. These are all the points you need to have in your mind. The resultant is an angular bisector. Okay. So I make a note of this point. Done? Done or not?
Yes, sir.
So I'm moving on to the next concept, that is multiplication of two vectors. So when you talk about multiplication of two vectors, it is like this. What are the two products we can do? One is dot product or scalar product, and the next is going to be vector product, or we call it as cross product. So what do you mean by dot product, guys? Tell me. A vector dot B vector magnitude of A vector. Can we be little fast? Magnitude of A vector.
Magnitude of B vector.
Yeah.
Cos theta.
Cos theta.
Cos theta. Okay, that's right. Next is, if suppose there are two vectors given like this, A vector is equal to A1 I cap plus A2 j cap plus A3 k cap, and B vector is equal to B1 I cap plus B2 j cap plus B3 k cap, then what is A vector dot B vector? What is A vector dot B vector?
Sir, A1, B1 plus A2, B2 plus A3, B2.
Very good. So can you give me an example of a physical quantity which is obtained by using dot product?
Work done.
One is work done. What else is there? Which you have learned this year. We have repeated so many times.
Flux.
Flux. It can be magnetic flux or electric flux. Okay. So there is another concept. Similarly, if two vectors are perpendicular, then what the condition will be? If two vectors are perpendicular, then A vector dot B vector will be 0. You know this, right? Because theta will be equal to 90 degrees. When you put 90, A will become 0. Similarly, when two vectors are parallel, what will happen? A vector will be equal to lambda times B vector. You know this also, right? One vector will be equal to lambda times an other vector. This is a condition when you have two parallel vectors. So, these are all the properties that are related to dot product. Similarly, what do you mean by cross product? What is A vector cross B vector?
Magnitude of A vector, magnitude of B vector, sin theta.
Is that all?
E cap.
N cap, N cap.
You put an n cap. This n cap is very, very important. Where this n cap is called what? It's a normal vector. We have applied this so much time this year, right? So many
Yes.
times we have applied. Normal vector perpendicular to both A vector and B vector. So this point has to be kept in your mind. And I'm sure you're pretty good with the concept of cross product. Right?
Yes, sir.
So these are all the concepts related to vectors that you need to know as of now. Anything extra needed, the direction, cosines and all, I will explain slowly as time progresses, because direction, cosines need not be applied in other chapter. It is restricted purely to this chapter. So we need not worry about it. So these are all the basics I wanted you to have before we start relative velocity concept, which is very important. Okay. So is there any doubt till this step?
No, sir.
Okay. Just give me a minute. So now I'm going to start relative motion. Okay. You'll understand why these vectors are important. So what exactly do we mean by relative motion?
So one body's motion with respect to another.
Yes. So in physics, relative means comparison. So when you do comparison, you can either do it in the term of difference or division. So here we are going to do a comparative study in terms of difference. Means we are going to see what exactly will happen for one object with respect to another. If suppose, if even before I go to the concept of relative motion, first let's try to understand what exactly relative means. Suppose I have a person of height h1 and I have another person of height h2. Okay, let me call this as the first person, second person. Now I'm going to put a question like this. What is the height of first person?
H1.
H1, no doubt in that. Height of second person?
H2.
Okay. Now I'm putting the question in this way. Height of first person with respect to second. What is the meaning of this?
H2 minus H1.
It is not the case. See, even before you told a mathematical expression to me. Okay. So height of first person with respect to second, you told h2 minus h1. h1, which is a mathematical expression. But even before we see what is a mathematical expression, my question is, what exactly do I mean by putting a question like this? Because here I asked you one thing, height of first person, and you people confidently told me it is h1. When I asked height of second person, you told me h2. But my question is, this h1 and h2 is with respect to whom?
With respect to ground.
No, here see, ground, you need to bring the ground into consideration only with respect to either, what do you call, when you talk about motion. Okay. So what I'm trying to ask is, this h1 is with respect to whom? This is the height with respect to himself. It is the absolute height we are trying to speak about.
Yes.
So when I instead of speaking height of first person, can I say what is the absolute height of the first person? Both mean the same. I'm just trying to find the English meaning behind this. That's it. Nothing else. I'm not trying to think in terms of physics at all. Listen to it carefully. If I ask you what is the absolute height of first person, you're going to say h1. Means is exactly, if you take a tape and start measuring his height vertically, he will exactly be these many feet or these many meters. That's what you're going to say, or these many centimeters, something. Similarly, if I ask you what is the absolute height of the second person, you will say h2. But if I put a question like this, what is the height of the first person with respect to second, then what is the meaning of it? Then the meaning of, let's visualize this. So this is the first person. This is the second person. This is the ground, okay, on which they are standing. Observe. You are using a tape to measure the height of the first person, which is h1. Okay. So you measured the height of the person from a reference point or a reference line. In this scenario, the reference line is ground. Need not be every time. They can stand on a table and also you can measure it. They can stand on a chair, anywhere they can do it. Right? In this context, I'm taking ground as the reference line. Similarly, you take a tape and measure the height of the second person, and the tape says this guy's height is h2. Okay, with respect to whom? With respect to the reference line. The reference line can be anything. Accepted? But when I say height of the first person with respect to second means, the first person's eyes, the first person itself is of this much height. So if I try to measure this distance, what exactly is the detail it is going to give us? What exact detail is it going to give us? See, mathematically, what will it give us?
H2 minus H1.
So if you give h2 minus h1, if I use the word minus, I'm saying it is purely subtraction. Correct? It is subtraction. So there are two things: difference and subtraction. What is the differentiating factor between them? What is the difference, guys? In some context, we say the difference between the parameters. In context, we say one parameter, one variable should be subtracted from the other. What is the meaning of this?
Difference can be negative.
Difference cannot be negative. What exactly happened? When I say difference, you report only the magnitude. Okay. When I say subtraction, you say negative. For example, the difference between 1 and 2 is 1 only. But 1 minus 2 is not 1, it is minus 1. So this is subtraction, this is difference. Are you guys able to understand? Am I clear or not on this point? So it's a very minute detail, but concentrate. Difference between 1 and 2 is 1. And difference between 2 and 1 is also 1. But if I ask you to subtract 1 from 2, you will say minus 1. If I ask you to subtract subtract 1 from 2, you will say 1. You will subtract 2 from 1, it will be minus 1. Okay. Now here I wrote H2 minus H1. Now my work is to convert this particular topic into a physics concept so that we understand what exactly we are supposed to do in physics also. Because here I'm dealing with something which is at rest. And what is my concept? My concept is motion. I need to understand what exactly is happening. Before that, I'm trying to get a clarity of what exactly relative means. Okay. So now combining all these points, think and tell me, what do we mean by height of the first person with respect to second? What is it, guys?
H1 minus H2.
H1 minus H2 is okay. No, I'm asking the English meaning of it. What do you mean by H? Because I have to speak in terms of observer. No? So what can you speak in terms of observer? Who is observing and who is being observed? Height of first person with respect to second means you're taking the height of the first person. First, we need to understand why it is H1 minus H2. Why not H2 minus H1? Okay, right? You might get this question because see, today I will tell you the answer, you will get the answer. You'll understand it. Let's say after 15 days, you forget the concept. How will you be able to recollect? There'll be a confusion in your mind, right? So the meaning of height of first person with respect to second is the first person's topmost point is taken as the reference line now. You're able to understand, guys? So initially, when I measured the height of the first person, who was taken as the reference line?
Ground.
Ground. So ground was taken as a reference line in both the scenarios, H1 and H2, both scenarios, it was ground. Whereas when I put a relative concept into picture, then what will happen is the thing is there, no? The observer will be taken as the reference line. So when I take the first person as the reference line, can I say height of the first person with respect to second is H1 minus H2. Okay, here I'm using subtraction. I'm not using difference. I'm saying it is H1 minus H2. Okay. According to the diagram, at least can you tell me what are you going to get? Will you get a positive value or a negative value?
Negative.
You will get a value which is less than 0. Okay, less than 0 is a mathematical expression. But my question is, what is the meaning of that less than 0? Suppose this guy is 4 feet tall and this guy is 5.5 feet tall. Then what is height of first person with respect to second? It is minus 1.5 feet tall. So how exactly are you going to interpret this number with the negative sign? That is the question. What exactly is your understanding? What exactly is minus trying to tell us?
The first person is 1.5 feet less than the second person.
Yes. First person is 1.5 feet shorter compared to the second person. This 1.5 is the difference and minus sign indicates whether the person is shorter or taller because in this context, it is a comparison of heights. Similarly, if I put a question like H21, it is going to be H2 minus H1. So answer will be 1.5 feet tall, which obviously we know. Here, why are we getting it as plus 1.5? Because the second person is 1.5 feet taller than the second. So it is a positive sign. So it's matching. I hope you're able to understand this, right? If I slightly extend this concept and put it across motion. So when an object is in motion, what are all the physical quantities that will be under our observation? What do we need to observe with respect to it? Hey, what are all the physical quantities that are related to motion?
Speed, distance.
You can talk about distance, you can speak about velocity, you can speak about acceleration. Okay. When you do this, let's see. Now, if I put a question like this, if I put a question like relative velocity, okay, that's what relative motion spoke about, right? If I speak about relative velocity, question is, let's say there is a car which is moving. Let's say there is a car which is moving with the speed of, with the velocity of VA. Why I'm using velocity is because I've used arrow mark for the direction as well. Similarly, there is another car moving with the speed VB. So what exactly does VA and VB mean? They are what velocities?
Initial velocity.
Sorry?
Initial.
There is nothing like initial. Let's assume they are moving with speed VA only. There is nothing like initial and final. Here, in this context, at least it is not changing. I told you already, right? H1 means what? Height of the first person. I told you there is another technical name for it. Absolute. So, this is the absolute velocity of car A. So, absolute velocity, I can either write it as VA or I can write it as VAG. Here, G refers to what?
Ground.
Here, G refers to ground. So, if I write VAG, then the formula is VA minus VG. In general, right, velocity of the ground is taken to be 0. And that is the reason why we write VA or VAG, which is the same. That is what absolute velocity of A. The meaning of it is, if there is a person standing on the ground and let's say in his hand he has a sensor to measure the speed, if the person is standing here, the sensor will be able to track the exact velocity of this person. That is the meaning. See, for me to give a better example, have you ever observed when you go on a road, there is, on the roads there will be certain speed limits for a particular road. Some roads will say you need to go at 40 km/h, some at 20, some at 60, some at 80. Right? These are all the speed limits, right? So beyond that, if you go, you have to pay fine. Okay. The question is, how will anyone know that whether you are crossing 80 or you are less than 80? What exactly do they do on road? Have you ever observed it? Let's say you go in a car. There will be some police standing here, right? And they will have a machine in front of them. Have you ever observed this, guys?
Yes, sir.
Yes or no?
Yes, sir.
You've done it, right? So let's say when this person is going with the speed, they'll stop certain people and they'll charge for them, right? But the question is, how are they able to know? So what exactly is happening is this sensor is there, right? It is going to measure the exact velocity of this particular car. Okay, when it is going to measure that value, it is going to give us the absolute velocity of this particular car, because the police is the observer. Where is the police observing from? Is he observing from the ground or is he also moving?
Ground, sir.
So he'll be able to measure the absolute velocity. So if a reading shows 80 km/h, that is the velocity of car A. Similarly, you have another car B that will show you 60 km/h. Now, let's say this person, the police wants to do a comparative study between the person A and person B. Okay, I hope you are able to understand till this point, right? Right. If he wants to do a comparative study between A and B, he will put a question like this: what is the velocity of A with respect to B? Meanings, what is the meaning of it? Mathematically, it is BA minus BB with a proper vector notation. Why am I using vector notation? Because I'm talking about velocity, right? BA vector minus BB vector. This idea I got it from here because height of the first person with respect to second, we told h1 minus h2. It is first minus second. Similarly, here it is first minus second, A minus B. I hope it is clear till this point. So when you do a comparative study, what is he going to tell? 80 minus 60, right? So it is 20 kilometers per hour. Guys, are you able to understand what I'm saying? I'll explain all the meanings behind it. But you have to give me confirmation. Are you clear till this point?
Yes, sir.
Yes, sir.
Right? I hope you're able to visualize because this concept should be visualized. Don't memorize it. So this is VA, VB. So what exactly do I mean? 80 kilometers per hour is the velocity recorded by the police who's standing on the road. 60 kilometers per hour is the velocity recorded by whom? By the same police standing on the same position of the road. Somewhere else also it is going to measure the same value. But one condition that is necessary is the observer should be stationary. That is the meaning. Now, what do I mean by VAB? What do I mean by VAB and what does this 20 kilometers per hour exactly trying to tell us? It's a positive value, first of all.
A is 20 this much faster than B.
Yes. So the person B, the person A is 20 kilometers per hour faster than person B. That is one way of understanding. Second is, instead of this police standing on the road, had this police been seated in car A and he's trying to use the same sensor to measure the speed of B, what will the speedometer, what will that meter record?
20 kilometers.
Sorry?
20 kilometers.
It will record 20 kilometers per hour. You have to understand this, guys. So, whatever recording or whatever values are happening is with respect to where the observer is. That is what the concept of relative velocity is. Okay? That is why we keep repeatedly using the word with respect to whom, with respect to whom. Okay? So, that is the meaning of VAB. Similarly, if the police was still sitting in the second car, VBA, then it would have been VB vector minus VA vector. What will answer be? Assuming they both are moving in the same direction. If you put an I cap here, here also I cap, here also it will be I cap. So VB minus VA will be 60 I cap minus 80 I cap. It will be minus 20 I cap kilometer per hour. So what is the meaning of this? So it will be as if the person in this car will feel as if they are moving with a speed of 20 kilometers per hour in the backward direction with respect to A. Actually, they both are moving in same direction, right? But it is a feeling that this person will feel as if he is moving in this direction with a speed of how much value? 20 kilometers per hour. You're able to understand why I'm saying it? Because this can be analyzed like this also, 20 into minus I cap kilometer per hour. So this minus I cap says he feels like that, but actually is not moving. Because you have done a comparative study, you didn't do an absolute study. On a comparative basis, the second person will feel as if he is moving with a speed of 20 kilometers per hour. In which direction? In the minus I cap direction. Have you ever observed this in a train? For example, you are sitting in a train. Okay, let's say your train has stopped in a particular station. You have a parallel track. And on the parallel track, let's say there is a train which is moving. Let's say there is a train which is moving in this direction. Can someone tell me what will you feel? First thing, will you feel as if you are stationary? Let's say this is moving with sufficient speed. So what will happen is you will not feel stationary in the first place. Actually, what is happening? You're at rest only, right? You're sitting here. You're trying to observe the train on the other parallel track. How exactly will you feel, guys? You will feel as if you are moving in the backward direction. Have you ever observed this?
Yes, sir.
You would have, right? So if this is the observer, if I take you as A and this as B, then VA minus VB is nothing but velocity of A with respect to B. Means the observer is in which medium? The observer is the train A. So VA minus VB, will this come out as a positive value or a negative value? It will be 0 minus something, which will definitely come out as a negative value. Whenever it comes negative, you will feel as if you are being pulled back. That is a feeling of it. Okay, that's not actually happening. I hope you are able to slightly visualize what exactly this concept is. Right? So, yes or no?
Yes, sir.
Yes, sir.
Right. So this is all about one dimension. Okay. This is all about one dimension. The same thing will get applied to the two dimensions. Okay, listen. Now what I'm going to do is, I'll give you some equations, make a note of it. Now I'll give you certain equations, make a note. So in most of the cases, what will happen is you can solve certain problems using equation of motion itself, but with the concept of relative velocity also. Okay. What I'm trying to say here is, we know there are three equations of motion. V square minus u square is equal to 2as. Let's start with the basic. V is equal to u plus at. Right. So these are the basic equations that we have in our hand, under where you can apply them under the concept of constant acceleration. That is understood. But the next question we need to understand is, you would have observed by now. If suppose I am applying these equations along y direction, what will I do? I'll put Vy is equal to Uy plus Ay into t. What is the meaning of this? You're saying the final velocity of the object in y direction is equal to initial velocity of the object taken only in y direction plus the acceleration along y direction into t. Accepted. In a similar way, what we can do is, we can apply the concept of relative velocity also. That is, VAB is equal to UAB plus AAB into t. So what is the meaning of this, guys? The relative velocity of A with respect to B is the final relative velocity of A with respect to B is equal to initial relative velocity of A with respect to B plus acceleration of A with respect to B into t. Are you guys able to understand this? Similarly, SAB will be equal to, can someone finish it? U it is UAB, and here it is AB, AB, AB. I hope it's clear. Right?
Yes, sir.
So this is all about
Yes,
one
sir.
dimension physics. It's a very simple concept and we have seen it. So here, when you're solving a problem based on relative velocity, what you can do is you can apply vectors as well into it. These things and all you already know. If I give you a vector, you know how to find the magnitude of it and all those things. Right? Next, let's do a simple problem. See, car A and B. I hope you're able to see this. There are two cars. Okay, car A and B start moving simultaneously in the same direction. So when they say same direction, it is relative velocity in one dimension. same direction along the line joining them. Car A is moving with a constant acceleration of 4 meters per second square, while car B moves with a constant velocity of 1 meter per second. At time t is equal to 0, car A is 10 meters behind car B. Find the time when car A overtakes car B. How to solve this? Don't look at the solution. You think what are all the procedures you will follow. We need certain questions, right? So when they are asking about time, one here constant acceleration, here constant velocity. So I'm clear that I can apply equations of motion. That is what these two keywords are telling me. If I have to apply them, how do I need to take them into consideration? So first of all, is this scenario possible? That is what we need to think. Is the scenario possible? I am thinking it is possible because of one factor. What is it? So logically tell me, if A has to overtake B, who should be faster? At least at one point, something should happen. Who should be faster?
A should be first.
A should be faster. Okay, there is a question. Now, is there a possibility for A to attain a greater speed compared to B? Question is there a possibility for A to attain a greater speed compared to B? The answer is yes. Why is it so? What keyword or what logic is telling me that yes, this is possible?
A has constant acceleration.
A is accelerating. Accelerating means its speed is increasing with respect to time, whereas B is moving with a constant velocity. Okay. Because see, why I'm telling all these points is because sometimes when they question you, right, there might be one of the options, right? This scenario is not possible at all. You have to verify that also. Because sometimes you do mathematically, you might get an answer which will lead you to wrong things. That wrong answer will also be there in the option. That's what they do. Okay, so you need to think of all these things. Since car A is accelerating, yes, it will be able to overtake car B. Okay, but what time it is going to happen, that's what we need to answer. So how do we solve? Can we apply equations of motion, guys? Can I apply equations of motion? Relative displacement of A with respect to B is equal to the relative initial velocity between A and B plus half into acceleration of A with respect to B. So what is the relative distance between A and B?
10 meter.
So 10 meter is equal to 10 is equal to. What is the initial velocity between A and B? Since no information related to A's initial velocity is given, you can take UA to be 0. So UA 0 means it is UA minus UB, the whole multiplied with B plus half into acceleration of A minus acceleration of B t square. So UA is how much? 0 minus what is the value of UB? 1, because it is moving with a constant speed of 1 meter per second. 0 minus 1 into T plus half into what is the acceleration of A, guys? 4 minus acceleration of B is 0 into t square. Solve for this, you will get two values of t. From that, you have to choose one. So value that are coming out as 2.5 and minus 2. Minus 2 is ignored because it cannot be a negative value. You're able to understand this?
Yes, sir.
The other way to solve this problem is, what is the other logic? How can you solve the same problem in another way? See, distance traveled by A can be UA into T plus half into AA T square, accepted. Similarly, distance traveled by B will be equal to UB into T plus half into AB into T square, accepted, these 2 points. What I'm doing is, instead of, let's say you didn't get the concept of relative velocity in your mind. You didn't know that you need to apply this. The other logic is, you're going to take the individual distances. Then what exactly is supposed to happen? For the car A to overtake B, first there should be some instant where they both are along the same line or along the, they should be like this. After this only the car will start overtaking. Let's say this is happening at 1 second. After 1 second only, the car will be able to overtake car B. Right? So this SA tells us the distance traveled by whom? This SA tells the distance traveled by the car number A. SB speaks about the distance traveled by car B. These 2 points, I hope it is clear. Right? So what is the initial distance of separation that is existing between them? That is 10. Right? So how much should be the exact distance A is supposed to travel to at least come in line with B? SA, so it is already traveling. So it would have covered certain displacement. To the displacement, it should have covered this extra 10 meters which was left behind also, so that it will be equal to the displacement of B at that instant. Did you understand what I wrote here? So A is traveling, covering certain distance. Along with covering that certain distance, it should cover that 10 meters so that it is able to totally cover the distance that is covered by B. Okay? So after this, you can do the same thing. So give me a confirmation. Are you clear till this step? This point is clear, right?
Yes, sir.
Okay.
Yes, sir.
Now, so what we saw till now is relative velocity in one dimension. Now there comes an important question: where to apply the concept of relative motion? How do we know? Like, say this problem is given to me, I need to solve this only using relative motion. Right? So there are certain keywords observed. So the concept of relative motion can be applied to 2 and 3-dimensional motion also. Okay, but mostly we'll concentrate only on 2-dimensional. So problems involving the concept of relative motion mainly belong to the following categories. The first category is, there is a concept called as distance of closest approach. That is, when you need to calculate the minimum distance between two moving objects, we apply the concept of relative velocity. How we are going to apply, we'll see it later. Second, there will be problems like river and boat or river and swimmer problems. Means there will be river, there will be a person who is swimming across the river, and when you need to do a comparative study, that time we apply. The third one is aeroplane and wind problems. These two are similar. Okay. Fourth one is rain and man problem. That is, there will be a person who's standing, and as I told you, rain will be falling vertically. Then a wind will be combined with it. Its direction will change. So mostly these kind of problems will be like, in what direction is he supposed to hold the umbrella, like that. Okay. And the next one is relative velocity in case of projectiles. This is a very, very rare case, but it is similar to the previous problem that you did. Depending on the problem, you have to do it. But these four are common. Why I'm saying common is because you have certain steps. Okay? You have a certain algorithm to be followed. You can blindly follow them and get the answer for any kind of a question. That is the main. Right? I hope it is clear. Yes or no?
Yes, sir.
So the first concept I'll teach little later because this involves a lot of mathematics. I'll teach this concept alone at the end of this discussion. We will start with river boat or river and swimmer problems. So at that case, what we are supposed to do. So that is category number 2, river boat problems or river swimmer problems. Okay. Now see, for you to speak about the concept of relative velocity, let's recollect from the logics that we have understood. Okay. So because, see, I'm just giving you an idea, guys. How you are supposed to think, I'm telling you. Whenever you see a question, you see that question and try to analyze what data you would need to solve that problem. Okay, that is what you need to do in the case of these exams. Okay. So here what we are going to do is, while solving the problems related to river boat or river swimmer, even without looking at the context, can you tell me what are all the details that we need to have in our hand and what is that we are going to deal with? So one thing we will, here how many objects are there?
2.
River, and it can be a boat or river, and directly the swimmer in contact with respect to the water. That can also happen. Both are same. Okay. So one thing is, what I need is, I need the absolute velocity of the river. Right? I see, for me to think about relative, I need the absolute velocities of all the objects that are involved in the process of relative. So I need the absolute velocity of the river, which is called as VR. I would need the absolute velocity of the boat, which is called as VS. VS stands for velocity of swimmer, or BB. BB stands for velocity of boat. So when I say absolute velocity, it is measured with respect to ground. Right? Then the last point that you will have is, you will have the velocity of the swimmer with respect to the river, because the swimmer is in the observation. The river is not being observed. We need to calculate how much time it is taking for the person to reach on the other side, or how should he move. Our interest of study is about the swimmer. That is why it is always velocity of the swimmer or boatman with respect to the river. That is what we need. So these are all the 3 data that we are going to have. I hope it is clear till this step. Okay. So all these points are theoretical. My question is, when I put it on a paper, like, what are all the directions I need to assign to it? That is the next question that gets raised. All right. So that again depends on the scenario. So here observe, it is a generic case. It is a general case where you have a river. You have a river like this. Okay. And the width of the river is how much? You have a river whose width is L. Okay. So you have x-axis, y-axis, because you are dealing with 2 dimensions. Now the next question is, if I take the velocity of the river to be to the right, meaning of it is flowing in the rightward direction. This is the absolute velocity of the river. If suppose, let's assume there is a swimmer who is starting to move in a direction which is making an angle theta with respect to the vertical, and let's call this velocity as velocity of swimmer with respect to the river. I hope this point is clear. Right? I hope these 2 points are clear. Why I wrote velocity of swimmer with respect to river is, with respect to the river, he has started moving in a specific direction, making an angle theta with the vertical, so that he will be able to reach the other end, depending on what conditions he needs to achieve. So what do I have out of the 3 parameters here? How many parameters we have in our hand? We have the velocity of the river and the velocity of the swimmer with respect to river. Now, what is going to be the absolute velocity of the swimmer? That is what we need to answer. What will be the absolute velocity of the swimmer? So here, now let's recollect the basics of vectors. So VR is a vector, VSR is another vector. How are these 2 vectors with respect to each other? What kind of a vector, what kind of vectors are they?
Co-initial.
So what can we think of? What comes to our mind?
Triangle.
Triangle or parallel? Co-initial, generally we say parallelogram. Why I am using parallelogram there is because for us to think of the diagonal, that's it. You have to understand one thing, they both are the same. But when you have co-initial vectors, you think in terms of parallelogram itself, because we need to recollect the concept of diagonal. So the diagonal which is starting from the common tail, maybe this is the velocity of swimmer. Because see, velocity of, if I take the resultant, the diagonal as r, then r will be equal to VR vector plus VSR vector. Accepted? Because r vector is equal to a vector plus b vector. So what is VR vector is? It is VR vector plus VSR is velocity of swimmer minus velocity of river vector. So this and this will get cancelled. So what is the resultant? The resultant will give you the velocity of the swimmer. Means if you need to attain the final velocity of the swimmer, what is supposed to happen? You need to have the velocity of the river and the velocity of the swimmer with respect to the river. Is that clear, guys? So that's what I've written here. Yes or no?
Yes, sir.
Okay. Listen. Now see what I'm going to do is, I'm going to analyze the velocity of the swimmer in both the directions. Both the directions in the sense along x direction and y direction. See what is going to happen. So I wrote it here. Velocity of swimmer can be written as velocity. It is, see, not a big deal. You can actually start like this. Velocity of swimmer with respect to river is velocity of swimmer minus velocity of river. So Vs will be equal to Vr plus Vsr. Okay. See. So the velocity of swimmer with respect to river is velocity of swimmer minus velocity of river, which implies Vs is equal to Vsr plus Vl. So when I velocity of swimmer is equal to velocity of swimmer with respect to river. So when I analyze it along x direction, then velocity of swimmer along x direction is equal to velocity of swimmer with respect to river along x plus velocity of river along x. Accepted? Now let's try to draw a separate diagram. This is VR. This is VSR. Correct? This is VSR. If I take this as theta, then who can be resolved into 2 components? VSR cos theta and VSR sin theta. Correct? Now observe. When I write velocity of swimmer along x direction, what is the velocity of swimmer with respect to river along x direction? Guys, I need some response. What is the velocity of swimmer with respect to river along x direction? You have it in front of your eyes.
Yes, sine theta.
V.
Yes, it is VSR sine theta. Now, see, I'm just doing a small change. Can I put it as minus I cap
Yes,
plus
sir.
velocity of river? I will write it as VR. Can I write it as plus I cap? I will just give a bar on top of it. So velocity of the swimmer along x direction is velocity of the swimmer sine theta minus I cap plus velocity of river I cap. So this will be VR minus VSR sine theta I cap. Correct? That's what they've written. In a similar way, you people tell me what will happen along y direction. It will be the velocity of swimmer with respect to river cos theta in the direction of j. Accepted?
Yes, sir.
So, can I write the velocity of swimmer like this? It is the velocity of swimmer with respect along x direction plus velocity of swimmer along y direction. Can I write it like this? When this is happening, it will be VR minus VSR sine theta I cap plus VSR cos theta. This answer is, okay, this is the general expression, or I can say this is the velocity of the swimmer. I'm repeating it. All these that I'm explaining is a general case. While you're solving the problem, only specific idea from this particular concept will be taken for application. Okay, so this is going to happen. Now, if I ask you a question, if I put a question like this, how much time does it take for the person to reach the other end? So how much time will it take for the person to reach the other end is the question. Okay. So if I say the time is t and the person will be able to reach the other end by covering a width of how much value? Okay. Right. Yes or no?
Yes, sir.
So time taken to reach the opposite shore. Can I put it like this? It is equal to the distance by speed. So time is equal to, what is the distance that is being covered? The distance he is trying to travel is n. What is the speed that is being contributed in the y direction? In the y direction, what is the speed? It is VSR cos theta. So this will be the time taken by the swimmer to reach the other end of the river. Are you able to understand this? So sometimes, why I'm saying this, see, for example, I'll show you a question. See, for example, this question is that the speed of a boat is 5 km per hour in still water. It crosses the river of width 1 kilometer. Width 1 kilometer is the length L. Along the shortest path in 15 minutes, the velocity of the river with respect to water. So they'll ask you something like this. Because time is involved, at that time you need to understand which formula to be used. It will be something like this. Right? So till now, I hope the discussion made some sense. Right?
Yes, sir.
Yes, sir.
Now, next question is, there will be certain scenarios that are coming into picture. For example, what they will ask us, Next is, what will be the drift experienced by him? Drift in the sense, what is the meaning of drift? So what is the meaning of drift? He will get carried away, right? Now my question is, he's trying to go from P to Q, but by starting at certain angle theta, are we sure that he will exactly go to point Q? Is there a possibility where he will exactly go and land at point Q? Or is there a possibility that he might land on the left of Q or right of Q also?
Left of or right of?
It can be anything. It need not be exactly opposite to Q, right? Because we never mentioned that he needs to travel in the shortest distance possible. We never use the word shortest distance. Shortest distance is the width of the river, right? So when he's going like that, he would have experienced certain drift. Means, with respect to Q, let's say he is reaching a point Q dash, then this distance is called as the drift experience. So what will be the drift experience by? Drift experience by the person will be, observe. The drift experience by the person will be velocity of the swimmer in x direction into the time taken for him to reach the point Q dash. Because what I'm doing, distance is equal to speed into time. Here I'm being concerned about the distance along x direction. That is why I took the velocity of the swimmer along x direction. So what is the velocity of swimmer along x direction? It is VR minus VSR sin theta multiplied with, what is the time, guys? Time is L divided by VSR cos theta. So this is going to be the drift. Is there any doubt? I hope you are writing it down.
Yes, sir.
So it is velocity of river minus velocity of swimmer with respect to river sin theta into L divided by VSR cos theta. Okay, I hope it's clear. No. See. So have this point in your mind. Now comes the questions. Okay, what is the condition for the swimmer to cross the river in the minimum possible time? Okay, so time that we have in our hand is T is equal to L divided by VSR cos theta. So make a note, if the swimmer is trying to cross the river in the minimum possible time, he should start moving exactly perpendicular to the flow of river. Make a note. So because T is equal to L divided by VSR cos theta, right? When will time be minimum? Time will be minimum when the denominator is maximum, because width of the river is fixed. So I can say time is inversely proportional to VSR cos theta. VSR is also fixed, so it is dependent only on cos theta. So for time to be minimum, denominator has to be maximum. Right? What is the maximum value that is possible for cos theta? The maximum value of 1. At what value is it possible? Theta is equal to 0 degree. So when we took theta, how did we take? Theta was taken with respect to the vertical. So with respect to the vertical, he should start exactly moving in the direction of vertical for this kind of scenario to be achieved. So this is what is velocity of boat with respect to. Are you able to understand? So that is the scenario when the question demands you about the minimum possible time. The next type of question they will ask us, what are the condition for zero drift or condition to reach the condition to reach the opposite point. So at that time, what should happen, guys? In this scenario, what should be zero? Zero drift. We have a formula for drift, and this should be equal to 0. When this is 0, you'll be able to reach the opposite point. So these two are the important conditions, and problems will be based on these two only. Are you guys clear with this?
Yes, sir.
So this is all about relative velocity in the case of a river and man problem.
Sir, will you be uploading this document on the app? Sir, I was unable to copy a few things.
I'll do it.
Okay, thank you.
So that's it. So that's it for this class. So what time is your school? 8:30 sharp?
8:45 for us, sir.
Okay. Need some time for breakfast. Right? So you guys can leave. I'll see you in the next class.